All right, good evening, everybody. My name is Daniel Song, and this is my partner, Emily Chen. We are members of Veritas BranchOut, a 501c3 nonprofit youth community outreach program. BranchOut was co-founded by Dr. Xiumin Liu and Dr. Richard Wong in 2015 and grew from 20 student volunteers to over 150 volunteers in 4 summers. Our student mentors come from over 40 schools across 4 states. As a community engagement program, we have received endorsements from the U.S. Congress, including Congressman Tim Kaine and former Congresswoman Barbara Comstock. Our Innovator program also won the U.S. Congressional App Challenge Award last year. As an award-winning program that works closely with our community, we have partnered with charter schools, community centers, and homeless shelters to provide STEAM support. As part of BranchOut's goals to promote STEAM education as well as civic engagement, we have put together a very informative career panel on the engineering field. Our panelists tonight are Ms. Xiumin Liu, a digital electronics engineer with Northrop Grumman, Mr. David Holmberg, a mechanical engineer with the National Institute of Sciences, and as well as Ms. Heidi Li, material engineering student at the Massachusetts Institute of Technology.
Thank you, Daniel. We are very excited to have our panelists here tonight. As Daniel mentioned earlier, our panel will be covering the general subject of engineering. The audience can expect to learn a lot in this career, and especially a couple of more specialized paths. We will also be covering how engineering in particular has been challenged and is reacting to the COVID-19 pandemic.
Yes, indeed, Emily. I'm sure we are all able to learn a great deal from our panelists tonight. They are seasoned professionals and hardworking students and are extremely knowledgeable. Tonight, me and Emily will take turns asking questions, giving time for each panelist to respond. In the last 15 minutes at 8:30, we will open the floor to the audience to ask questions about the field. So without further ado, let us get into our panel tonight. So, what inspired you to pursue the engineering field?
Daniel, you want to direct it to one of us, or
Sure.
how do you want to know that?
All of you will get a chance to answer, but for now, let's start with Dr. David Holmberg.
Okay, thank you. So, engineering, I think there's some students who know what they want to do, and then some students who don't know what they want to do. I mean, I always like working with my hands, and engineering was kind of a good fit. Mm-hmm. I didn't have a clear idea what I was going to do with it, but it was it just seemed like a good fit, and so I went and studied mechanical engineering.
Yep, pretty cool.
So I think my bachelor degree is from physics. Actually, that's starting the hard part. We learn a lot of the topics in the quantum and the physics, and I think during the master and the PhD, I started to switch to the electrical engineering field, and I learned what's the optical field, and especially major in the fiber optics, and work on a lot of the design, and also facing a lot of challenge. I think that's the part actually make me go down to the path to enjoy the beauty of the engineering field.
Yeah, for sure. Thank you.
Yeah, so I knew basically from a young age that I've always liked science. And what really drew me to science was especially the problem-solving aspect of it. So being able to diagnose problems and find solutions. I just thought that was a really creative process. And so engineering seemed to be the best outlet for this creativity and my love for science. So yeah, that drew me to engineering.
That's definitely really cool. Thank you, all of you. Emily, would you like to take the next question?
Sure. What part of this job do you like the best, and what do you not like as much?
So I'll start. In my job, I have a small team at NIST, but I spend a lot of my time interacting with people outside of NIST, whether it's in standards committees or industry organizations where we're working on some tool to put in the hand of I work with electric utilities. I work with vendors selling to utilities and to buildings and building owners. So I get to work with these different groups of people on different projects, and I really enjoy that.
Heidi, you want to go ahead?
Yeah. So I'm currently working with a group of researchers and other students. And I think what I really like about it is being able to bounce ideas off of each other, and the collaborative brainstorming process, I think, is really fun because you never really know what other people are thinking, and being able to kind of be influenced and inspired by their creativity is, I guess, just a feedback loop. So I really enjoy that process.
That's good.
Yeah, I think for me, I really enjoyed, a lot of challenges I'm going to facing, not every day, but, consistently you need to resolve the problem. And especially, you are not doing repeatable work every day. That's always something dynamic, and you need to resolve the problem. I think sometimes it's upside down, and when I try to resolve the problem one day, I facing, I can't resolve it. That's make me, what's wrong? And I think I have to look all over the place, think through all potential the root cause, and but eventually I will, figure out the solution. That's the happiness I will enjoy the most, because that will make me feel so good and, be confident to work through. And, sometimes the challenging part is you need to coordinate with other people and track a lot of work. And also, you can't expect everybody, to keep the same pace. I think you need to negotiate a lot of things, and also, collect all the resources you need to work through. So that's something always need to, that's a kind of not linear way, like you resolve the problem eventually, but you have to work with people to figure out the solution. So I think that's something always, related work. Yeah.
Now, what are some challenges that you think that are in the career field, Dr. Holmberg and Ms. Heidi?
Did he left?
You can go first, Heidi.
I guess I can go. So I think it's hard because there's always challenges, and it's hard to, I guess, pinpoint them. But I think for me, one of the challenges, so I guess maybe I can just backtrack and introduce the project that I'm currently working on. So I'm really interested in energy, and specifically energy policy and how that relates to technology. And so I'm currently doing a research project looking at Pennsylvania and decarbonizing Pennsylvania, because Pennsylvania is a coal-producing, natural gas-producing country. And so really trying to get state, and really trying to get this state to decarbonize will have its own sets of barriers. And so then I think one of the challenges is to really be able to talk to your stakeholders and really understand the problem. I guess in general has always been one of the hardest parts, especially in the design process, just to being able to pinpoint and fine tune a problem statement and really try to address the problem using an appropriate solution. Sorry, that was a lot. But I think one of the biggest challenges is definitely problem definition and diagnosing.
No problem. Dr. Holmberg?
Yeah. Sorry about that. I like what Heidi said. I like what Xiumin said about Heidi about defining the problem and the challenge of tackling it. And I think Xiumin said the similar things about working with people, negotiation. I think in my job, I've had the opportunity to serve on some international standards organizations where it's like you're dealing with the positions of different countries and developing a solution, and different, whether it's a country or a person, different people have different ideas. And the field I'm working in now with smart grid is So the goal is to say, how can a building participate in a way in how we use electricity so that as we move towards more renewable energy, we use energy when the sun is shining or when the wind is blowing, but we don't use energy when the wind isn't blowing and the sun isn't shining. And so we don't want to have to spend too much money on batteries, so we use other kinds of storage or just manage when we use energy. My point was different people have, the technical solutions are mostly there. It's not like cutting edge science. It's really more the politics and negotiations among people that make it so interesting. About different stakeholders have different positions and different ideas, and different companies have different technical approaches, and they don't interoperate. And I care a lot about, as a standards at NIST, it matters a lot to have interoperability.
Thank you. What advice would you give to somebody seeking to enter into a similar career path, Ms. Xiumin?
You mean the similar career path? I think, I think it's hard to say. I guess, the most important thing, especially, the first thing, you have to work hard, right? And because you really need to resolve the problem, not just coordinate a lot of works, and also you really need to work with others and figure out the solution, especially sometimes it's hard problems. And also, another skill, I guess, is not waiting less, is to work with people, because there's no single thing you can accomplish with, by yourself. You need to work with different group and different managers. Also, in general, we work a lot with the technician, right? And, for example, if your board needed to solder something, apparently you want to achieve your goal as soon as possible, but a lot of time you need to rely on the technician to work with. So keeping good working relationship is critical, because, even just tiny components, you need to put on the resistance on that board. Literally, you have to work with people. And if people give you the green light, and that will achieve your goal faster. Otherwise, that will be, week later. So that's why you need to have the math skill to work with people. Meanwhile, I think a critical part is you have to work hard on your, knowledge side, because that will, give you more opportunity to say, okay, you are a good engineer, you earn more, respect to other people willing to listen to you more. I think that's something, not only the technical perspective, also a kind of a social skill, work with people.
Yeah, that's good.
Yep. Dr. Holmberg and Heidi, do you have anything to add?
I would agree with what Ms. Xiumin said. I would say also look for the something you're interested in. Of course, if you're not interested in it, you're not going to enjoy your job. And then look for something cutting edge. And so much of our world is intertwined now, where it really pushes that you have to work with people. So
For sure, yeah.
But if you have some technical knowledge, you pursue some cutting edge thing, then you can integrate that with some other technology and really accomplish some interesting and rewarding things.
Yeah, and to add on to that, I want to say just to be open-minded, because engineering is such an expansive field, and it covers a lot of facets of different fields like medical, energy, etc. And so really doing your research, talking to professionals, conducting informational interviews, just whatever you can do to, if you're interested, just try to do as much research as possible in these fields and see if this is something that you can see yourself doing. And of course, being open-minded to change. to know that not everything will work out right away. Yeah.
For sure.
Yeah, I think Heidi bring up a pretty good point. Don't afraid of change. I guess I can share a personal experience I did before. The reason is just because I used to be working in the telecom field as an optical engineer, and actually we didn't work with the electrical, the RF field too much, mainly in the optical field. So all my background is, even my PhD is in the optical field. And I think, a few years ago, when I switched to, the Northrop Grumman, I think that's a pretty big change, because totally away from the optical field to the pure electrical field. I think, there's no anything related to optics anymore. So when I switched this career path, I was kind of scared, actually, to be honest, because I think, I'm good at the optical engineering field, but suddenly I need to go to a step, especially go to a kind of chip test and also RF field. That's a dramatic change. So I was thinking about, is this a good move? And, should I do this way? And can I be good at what, this change? I'm kind of scared, but after I joined this new company, I think, I didn't take too long to switch this new field. My personal experience, I just feel a lot of knowledge actually is connected. After you know a lot of fundamental stuff, you have a mindset in my mind to resolve the problem. You will say, okay, actually you can do good still, even you switch field, as long as you can keep learning.
Thank you, guys. Emily, would you like to take the next one?
Yeah, so thank you for your advices, and thanks, Ms. Jung, for your little story. So next question, what skills are necessary for your career path?
I can go first. So I'm still a student. I don't really know, I guess, too much into the future, but I can imagine maybe a super important one is communication. Because no matter what you do, whether that's presenting to your professor about the research that you just did this past week, to giving meetings and hosting about meetings about your findings, just being able to communicate effectively and succinctly what you found, the ideas you have, what you propose in any field is crucial.
Yeah, I agree with that. I think at NIST, the environment is quite academic, kind of a researchy environment. It's a research laboratory. Communication, but it doesn't matter. Communication is super important, whether it's your boss or the customer or your colleagues or writing a paper where it gets really, I've had to learn some hard lessons about how to write. Like, I thought I could write coming out of college, and then my boss would just rip up my, rip it up, just read all over it. Like, where did you learn to write kind of thing. I guess that's just a different point, that it's an ongoing learning, all through your life, and your career path can change, just like Ms. Xiumin was saying. So same with me. I went to school, I focused on heat transfer, I did a postdoc on heat transfer, but in the end, I'm not doing heat transfer. So things change. So flexibility, curiosity,
Right.
Hard work, all those things that Ms. Xiumin was just saying.
Right.
For sure.
I think, especially at the earlier career stage, and be active, be willing to learn, and also, eager to learn. I think that's a very important factor to demonstrate you want to learn. Especially, I think, in any organization, you always have some senior peer person. They are willing to share the knowledge, and also, they want to share that. But I think, that only can be happened until you are eager to learn and active to ask and, try to approach people. And that will help you dramatically to say, okay, this is a good, the young guy to, to join this company, and also, take some risk to take more responsibility, especially, there are always some people around, and if you need help, people will help you.
Mm-hmm.
Yeah, I want to add also to David and Xiumin's point, sometimes you just have to be the one to push yourself off the bridge into the deep end. And so trying something that you don't know if you like or that has never occurred to you could actually turn out really well. Before this year, I was actually dead set on doing something in the medicine field or something in big pharma. And then I had a conversation with someone about energy, and I completely did a 180 and I'm now obsessed with energy. So definitely don't be afraid to try new things and to take big risks and be ambitious.
Thank you. So Heidi, as an MIT material engineering student, could you tell us a little bit about your typical student life on campus and what kind of advice you'd give to prospective college students into this field?
Yeah. So I guess before quarantine, I was taking about 4 to 5 classes. And so I'm a materials engineering student, but I'm concentrating in energy and policy. So I'm taking a few humanities classes as well. And so outside of classes, I found that work-life balance is extremely important. And so I'm also involved with volleyball. A few times a week I'll go and practice, and also I'm part of an organization called Sustainable Energy Alliance, so we do education outreach. And so just having your studies also be supplemented with, for me, like the extracurricular, I think is really important to be able to connect the dots between what you're learning in class to real world applications. Because not only is that important to realize what's happening in the real world, but also it gets you more interested in the classes because you're seeing, oh, wow, this actually isn't just a problem set on paper. Yeah.
Cool. Thank you.
The next question, how has engineering changed over the past 5 years and 10 years? And what is going to be the future of engineering in the short term 5 to 10 years? Can any of you give some specific examples in your field or both?
This is David. I'll just say that, so like Heidi was saying with energy is huge right now with the whole shift. I mean, the whole climate change and shift to renewables. That's what my job's about now, or what's driving my job. And so that's something that impacts all kinds of engineering fields. Of course, the virus impacts a lot of things too. I mean, I think we'll talk more about that, but
we'll get to that.
I'll just say that. Yeah, I'll just say that.
Yeah, I think because I was coming from the telecom field. I think one moment, I think in the future, going forward, the cloud, the database will be a mainstream for a kind of networking stuff. Eventually, I believe, at this moment, I think, a lot of things we still save the local computer. Eventually, we will save everything, include, the pictures and the personal files, everything will go to cloud.
Mm-hmm.
And I think the AI a big trend as well in the industry, and also the 5G stuff, and that's connect everything. And I guess right now we are seeing the smart home. Eventually, that will be the smart city, smart country. That's a big move as well in the telecom.
Yep.
Yeah. So I haven't been in the field for too long, but I think one thing I'm really hoping that engineering embodies is more social engineering in the sense of keeping in mind the social implications that technology has and ways we can mitigate potential risks. So right now, especially with the Black Lives Matter movement going on, really being able to see how technology can help bridge the gap, the social and I guess privilege gap, and hopefully using technology for the better and really trying to innovate that area. I guess like the example that comes to mind is a lot of things that like traditional energy, especially the coal fire plants, are in a lot of places where the land is really cheap, and because of that, a lot of underserved communities also live there. And so then it poses a health risk for these communities, but because the land is cheap, they are only able to, I guess, live there. And so it's just a feedback loop. And so really being able to get away from this, I'm hoping, can be the future of engineering.
All right, thank you. So how does the current pandemic impact your jobs, pros and cons, and how did you guys handle it? Heidi, could you share a little bit from the students' perspective also about the pandemic, but for all panelists?
Yeah, so before we were, I guess, evacuated from campus, I was taking a class that had a lab component to it. So every few weeks we would go into the lab and have lab reports and experiments to do. And so when we became virtual, that component of the class got completely, I guess, renovated. And so then I wasn't able to participate that, which I was really looking forward to. But yeah, so less hands-on learning, but still a lot of classes and virtual content, I guess, and lectures online. And in terms of my current project, so we were starting remote, but because we weren't doing actual experimentation or wet lab research, it didn't get impacted that much.
That's cool.
I'll just say, like a lot of places, NIST went remote. And for the past 3 months, it's only been the critical, like the IT folks and some people on campus. Now they're bringing some people back for laboratory work. But it hasn't impacted, I think, engineering in general. I just look at the virus is going to have a big impact on our economy, just with all the, I hear bankruptcies every day. And I mean, it's going to have a serious impact. And that's the main impact of that is going to be there's not as much work. It's going to be harder for students to find jobs because, I mean, it depends what field you're in, but I think that's going to be the reality maybe for several years going forward. Is just there's less work out there, and that puts a crimp on, the creative, fun things you can do with engineering.
Yeah, potentially, limited some research work as well. I guess, the funding stuff. Yeah, for me, I think it's less impacted. Even I work, I think, a few weeks at home most of the time because I don't know, how hard the pandemic lasts, and also, I'm kind of scared about this virus. But in general, we're still working as usual. And recently, I guess, we work still intense in the lab, and we didn't impact too much through this, special time.
That's good.
Okay, following up that question, what has the engineering field done to help flatten the curve and make the pandemic less harmful?
Well, I'll just say the management at NIST has been very proactive and kind of threw it out to the engineering lab staff and said, hey, what can we do? And so we were able to help with some studies on indoor air quality and some things related to masks and I don't know, a bunch of different things. But I think it demands engineers to kind of step up and deal with the real world problems and figure out how to deal with them.
Right. I think some statistics about how to build more reliable model by using different algorithms, right? And also, how fast we can get the vaccine as soon as possible.
Yeah, definitely.
And also keep, the reasonable social distance. And also that's, related to engineering world to simulate all kinds of, this kind of samples, and also, how many people infected, and when's the best time to reopen. I think that's rely on a lot of models and simulation and technical information as well.
For sure.
Yeah, from I guess the materials perspective, I think a lot of it comes down to PPE and just navigating the supply chain where there are shortages, where we can import certain materials. Are they FDA approved? So it's quite a dynamic problem and definitely very nuanced, but trying to figure out, can there be material substitutes, and where can we find such material, stuff like that. And really being able to then track it down and then create new PPE or as, I guess, demand increases.
Quick question, Heidi. What is PPE exactly?
Oh, sorry. Personal protective equipment. Yeah.
Cool. All right. So it's 8:31, and I will now open the panel up to questions from the audience. So feel free to ask your question in the chat box, and then I'll have the panelists answer. All right, Andrew Yang had a question. What do you think is the best way to showcase your passion for engineering? Could we start with Miss Heidi, please?
Yeah. I think the best way to showcase your passion for engineering is to do a project you're super passionate about. Maybe you can talk to some mentors or cold email professionals and or professors, but just do it, basically. Whether that's building some kind of robot or creating an app, I guess the best way for you to really showcase your interest is to be able to prove and show oh, look what I did. This is something I'm proud of.
Mm-hmm. Yep.
So Jonathan Wu posted in the chat box, what exactly does NIST do as an organization, and what are its responsibilities?
So NIST, NIST is it's a national laboratory. It's in the Department of Commerce. Most of our funding comes from Congress, and we do basic research to support standards primarily. So we don't write the standards, but almost all NIST staff are involved in different standards developing organizations. So I'm doing research around understanding how buildings and building equipment can engage with, say, electric utilities and markets to, like I said, use power when it's available and not use it when it's not available, and all the communications required to make that happen. So NIST does a lot of different topics. I'm in the engineering lab, but there's materials, physics, you name it, a lot of stuff.
Mm-hmm.
Yeah.
Cool. Someone asked, are there any notable resources that you've used to help you study or learn in your career?
I think I can answer this question. I guess, the first thing, I think, intense study that's coming from the school, but after you go to the work, actually the most, the notable resources is your coworkers, and also, and searching online, use Google, and keep learning by yourself. And that's the most important thing. And also, I think one thing I want to say is you can't know everything. you always have your limitations. So that means if you do your job, don't hide, you don't know. You need to learn by yourself, and also you need to reach the resource to learn from others. And that's the teamwork. We always need to work together and learn by yourself and learn from others. So that's the most important skill, and how to approach people and reach people, and how to get the necessary support. So that's the resources. Actually, especially when you go to, careers path more, that's a kind of skill you need to get, how to, utilize different resource to work on your, task.
Yep. Jerry Gall, we already touched on what you guys really enjoy about your jobs, but Jerry Gall was also asking about what do you like the least about your jobs? Or careers in engineering.
I think so far I like what I'm doing. I guess, I was in the design team. I enjoy what I'm doing. And right now I work, a kind of more production side and work more, interact a lot of people and, coordinate a lot of work and, also resolve the problems in the lab and the product you are in charge of. I think the most important thing, I guess, no matter what, enjoy what you are doing, and also try to learn each field you are going to in charge. I think that's something I want to share.
Yeah. Heidi, go ahead.
Oh, I wasn't saying anything.
Oh, okay. No, I was trying. I'm not sure I can pinpoint anything. I think I enjoy working with people, but then working with people is challenging sometimes, and
that's true.
and an organization can be great, but then you still have to deal with corporate culture and management and
right
communicating, and there's always challenges. So.
Right.
Sometimes you want to do something and you don't know how to do it and you can't figure it out. Well, then you have your team, but then sometimes you're just beating your head against the wall. And
yeah, for sure.
Yeah.
Yeah, I think one thing I've also found is that I'm kind of one of those people who wants to see results, whether or not that's like right now or in the future. But I think what's really challenging right now is I'm doing all this work, but I don't know how it's going to be implemented in the future. And so I guess the unknown of the future is something that is slightly unsettling, but I guess that's also what makes it really interesting and intriguing in the first place. So.
Yep.
So I guess we can move on to the next question. So someone said, if he is a computer science interest, but he's not sure if engineering is like the major for him, so what advice would you give for him for choosing whether or not to do engineering?
I would say that they're not mutually exclusive, and that you don't have to pick just computer science or just engineering. There's definitely overlap. But in terms of trying to understand if you like engineering, I think what really helped me was also just to talk to engineers and see if you like what they do in their daily work, and I guess what motivated them to become an engineer.
And also, I think I want to add about the engineering. I think, literally, probably, I think you guys mind engineering is just doing some technology. Actually, this is just one aspect. Engineering is a very broad range and need a lot of, the skills, not only doing the research and doing the engineering development, and actually there's all kinds of different fields that's related to the engineering. For example, in the big project, there's some program management position, and also, there's some supporting, position as well. And also there's some coordinator for the big project and the schedulers, all kinds of aspects on this engineering field. So I think go ahead to try it. And if you don't like it, and you always have some opportunity, especially in the company, they offer all kinds of scholarship for you to continue learning and in a different interest, and keep exploring what's your interest, and keep. But no matter what, keep learning, keep trying, and figure out what's the most part you like, and then you will figure out eventually what you can do, what you are good at.
Yeah, I think I would just add that computer science is a really key part of engineering now. I mean, so much of what we're doing is tied to something online, or tied to whether it's artificial intelligence or it's machine design or it's whatever. Everything involves computers and programming. And if you go the route of computer science, you're going to be part of a team that, in an engineering company, or maybe you'll be pure computer science, go work for Google or something. But I always thought of engineering as, more hands-on, but not necessarily today, I guess.
Right.
Definitely.
There's, divided all kinds of different field, right, applications.
Yeah.
Mm-hmm. All right. Does the audience have any other questions? All right, I had actually one final question. How has the industry changed since you guys first started? Yeah.
Wow, 20 years ago, there was 30 years ago, it was kind of like internet was just being born, and people didn't even have cell phones. And, that's just been a huge change, how everything has moved online and become so much more interactive, even that we can sit and be on a call like this and see each other's faces. And, I don't know, a lot has changed around that side.
Yes,
Mm-hmm.
That's true. Definitely. I think even we don't need to see too many years. You go back to 10 years ago, right? There's a lot of change, or, especially I think I'm away from telecom, but, from telecom perspective, there's a lot of dramatic change. You can see, the cost for the internet and the phones, everything goes down. Actually, the capacity and the bandwidth and the features going up dramatically. This is actually a kind of a revolutionary change, and also there's no sign to say it's slowed down. Actually, it's speeding up. Yeah. But I think, for technology side, I always keep, my personal opinion is good and bad. Bring up some good side, but also, isolate people in some extent because we utilize the technology too much.
Heidi, I know you were recently a student as well, but is there any changes you noticed while studying as a junior?
I'm not sure. I guess I've always been really tied to technology. I think in terms of studying, so I recently moved to digital notes. So I've been using my iPad to take notes, and I think I've seen a large shift in students just being able to do that. And I think, one, it's really good for the environment because you're not using paper. But another thing is just having the convenience of everything being on the cloud and right there on your laptop, or when you open your iPad, I think is great.
Definitely. Well, all right, that would be all the time we have tonight for questions at 8:45. On behalf of the whole BranchOut career panel team, we hope that everybody has enjoyed the panel this evening and learned a great deal about engineering. We hope that everybody got a chance to experience the essence of engineering and had their questions answered about the vital field of STEM, even being inspired to pursue or further research engineering. STEM has become a driving force for innovation in the 21st century, and all throughout history, it has contributed greatly to mankind. It is clear that the STEM career will be driving the future, making the world a better place. We are also extremely appreciative of the panelists Xiumin, David, and Heidi for their time and giving us such great insight into this field. We are also very appreciative of our audience members for making this panel so great and asking some wonderful questions. To learn more about BranchOut and our future panels, please check us out at www.velbranchout.org or like us on Facebook at Veritas Education Leaders. We look forward to seeing you at our next event. Thank you, everybody.
Thank you for this opportunity. Thank you.
Thank you, guys.
Thank you very much.
Okay, have a good night. See you guys.
Bye.
Have a great night, everybody.
Okay, thanks. Bye.
Bye. Thank you for hosting.
Thank you,
Nice
guys.
to talk to you guys. Yeah. Bye.
Bye-bye.
Bye now.